right, today we're going to look at lesson 10.3, and you'll notice the title says Solving Radical Equations. Now, I want to focus on the word radical for just a minute. All right, what is another word that we have used for a radical? Anybody remember? Square roots. All right, very good. So square roots and radicals are the exact same thing. So if we are going to be solving radical equations today, what do you think these equations are going to have in them? Square roots or radicals. Okay, they're radical equations, so they're going to have radicals or square roots in them. Okay, another reason I would pay really close attention and write down anything extra that I give you is because this is also going to be the topic of your next journal entry. So those of you that struggle to write a half a page on a concept that is not that difficult, you want to pay attention today to how I'm teaching it. And if I have you add something to your notes, go ahead and add it to your notes. All right, the essential question for today is, how can you solve an equation that contains square roots? And we already talked about a radical equation. It contains a radical expression, but I want you to pay attention to this next part, with a variable in the radicand. So let's talk about the radicand. Where do we find the radicand in a radical? Nope.
Inside.
Under the radical. Okay, the radicand is that information, that number, that variable, that expression that is underneath the radical. So what this is telling you is not only is the equation going to have a radical in it, but it's going to have a variable under the radical. All right, and that's why we can't leave the radical in the problem, because we need the variable to be isolated. We need to solve for the variable. Now, extraneous solutions. This is another thing that is very common when you're solving radical equations. Okay, when you plug your solution back into your original problem and it does not make a true statement, it is considered an extraneous solution and we're going to mark it off. It's not going to be one of our solutions. So typically I tell you, you can check if you want to, but with radical equations, we're going to have to check every single time. All right, so let's look at example number 1. It says solve the equation and check your solution. Now here's the first thing we look for. Okay, and this is the first thing I would add to your notes. Okay, right near example number 1, maybe right underneath it. The first thing we have to do is we have to isolate the radical. We have to isolate the radical. Now you can call it the radical part. You can call it the radical piece. I don't care what you want to call it, but we gotta isolate the radical part of the problem. All right, that's step number 1. So if you're looking at letter A, is the radical part of the problem isolated? Is it on a side by itself? Yes, it is. All right. What is the radical part of this problem? The square root of x. That is the radical piece. That's the square root. Okay. So here's what I want you to do. I want you to take the square root of x equals 6. And I want you to rewrite it because we're fixing to do something to the problem. And when you're looking back to study, as I know you guys are going to do, I want you to be able to see what the original problem was. Okay, so we're not going to do the work directly on the original problem. Now, if I want you to think, because you know the answer to this question. If I want to get rid of a square root, how do I undo something that has been square rooted?
Square it.
You square it. So that is all we have to do. We are going to square both sides of the problem. So, what is the square root of x squared? No, it's not. Okay? Think about it for just a second. Remember, we learned this shortcut. The square root of x squared is the square root of x times the square root of x. When you multiply a radical times itself, what do you always get? The thing under the radical. So every time we square a square root, we are left with what is under the radical. So this is x equals, what is 6 squared? 36. Now, we're going to box it in. But then we're going to check it. So we're going to go back up here. We've got the square root of 36 is supposed to equal 6. What is the square root of 36? 6. Does 6 equal 6?
Yes.
We're good and we can move on. It checks out. All right, now look at letter B. What is or is the radical part of the problem isolated? No. So Xander, what is the radical part of this problem? Square root of y. So this is the piece. Now if this helps you, do this. Circle the piece that you're trying to isolate. We want to isolate the radical part. So we are right back to chapter 1, basic equations. how do we move that 15 to the other side of the problem? We subtract it from both sides of the problem. So we have the square root of y equals, what's 22 minus 15? 7. All right. Now that the radical part is isolated, what is step 2 to solving these problems? Okay. So we can even add that to our steps. We isolate the radical part and then we square both sides. So I didn't put it in the notes for you, but I would add this. Square both sides. And that's exactly what we're going to do to letter B. We're going to square both sides. So what is the square root of y squared? Y. And what is 7 squared? 49. All right, let's go ahead and box it in, but remember we got to check it. So we've got the square root of 49 plus 15, and it's supposed to equal 22. What is the square root of 49? 7. And what is 7 plus 15?
22.
Does 22 equal 22? Yes. Then we can move on. Now I want you to work letter C with the people at your table. Right? What is the radical part of the problem that we're trying to isolate? The square root of C. So, Deslin, what did you guys move first in your quest to get the square root of C all by itself? How did you move it? You subtract 1 from both sides. Perfect. So we have the opposite of the square root of C, and it equals -3. All right? Amelia, what did you guys move next? Very good. Did you guys all recognize that there was an understood -1 in front of the radical that has to be moved? If you did not, go back and fix it, okay? You're supposed to have divided both sides by -1 so that the square root of C is equal to, everyone, what's -3 divided by -1? 3. Now, how do we get rid of Chase, the radical? You square what? Both sides. We square both sides. So what is the square root of C squared? And it equals 3 squared, which is 9. Now, how many of you forgot to move the -1? Raise your hand. Okay. But how many of you still got a +9 as your answer? Okay. And you will, because you're squaring, whether you square a positive number or you square a negative number, your answer should always come out to be positive. Okay. But that will not take away from the fact that you'll lose points because of your steps. So be very, very careful. All right. You cannot square a negative square root of C and just get a C. All right. Now let's check it. We have 1 minus the square root of 9 equals -2. 1 minus, everybody, what is the square root of 9? 3, and it equals -2. What's 1 minus 3? -2. Does that check out?
Yeah.
Then we can move on. Now that takes us to letter D. So the steps are still the same. Okay, this one looks a little bit different because what is now underneath the radical? What do we call it? It's got 2 terms. What do we call it? A binomial. All right. So just because we go from a variable underneath the radical to a binomial underneath the radical doesn't mean anything changes. All right. We still want to isolate the variable part of our problem, which in this case is the square root of x plus 4, which means, Kayla, we're going to have to move what to get that by itself? And how are we going to move the 7?
By subtracting 7 by both sides.
Very good. We're going to subtract 7 from both sides. So we have the square root of x plus 4, and it equals, everybody, what's 11 minus 7? Good. Very good. All right. Now, is the radical part of the problem isolated?
Yeah.
So what is step number 2? Square both sides. So we are going to square both sides. Now, what is, Jaden, the square root of x plus 4 squared? It's x plus 4. Very good. So nothing changes. If we take the square root of something and we square it, we're always going to get whatever is under the radical. So x plus 4 equals, what's 4 squared? 16. Now here's the difference. We're not done because we have not solved for x. So Travis, how are we going to solve for x? We're going to subtract 4. And so x is going to equal 12. So we'll box it in, but don't forget we got to check. So I'm going to check it down here. You check it wherever you want to check it, but I'm going to check it below this time. We've got 12 plus 4 plus 7, and it's supposed to equal 11. So what is, if you grab your calculator if you need to, what's the square root of 12 plus 4? 4, because 12 plus 4 is 16. The square root of 16 is 4. So 4 plus 7 equals 11. Everybody, what's 4 plus 7?
11.
Does 11 equal 11?
Yes.
Then we move on. Now look at letter E. What do you think? I want to hear some ideas. What do you think that we're going to have to do first to this problem? Blake.
Square both sides.
There you go. There's a radical on both sides. So technically the radical part is isolated. So all we have to do, now this is another one where I would rewrite the problem. So if you go back to look at it, you know how the original problem looked. But he is exactly right. All we have to do to get rid of the radicals is square both sides. So what is the square root of 3x plus 1 squared?
3x.
3x plus 1. And what is the square root of 4x minus 7 squared? 4x minus 7. Now guys, we are right back to chapter 1. We've got to solve an equation. So if you need to be reminded, what's the acronym that we've used for multi-step equations over and over again?
Don't call me after midnight.
Very good. Don't call me after midnight. So if you need to think through that, if you need to write that down, write it down. But let's think through it. Don't distribute. We don't have to distribute. Call, combine like terms. Do we have any like terms on the same side to combine? No. Me is move the variables. Do we have a variable to move? Yes, because we have a variable on both sides. Which variable do we want to move? Does it matter really? Okay. It does not technically matter, but we do like to get our variable on the left side of the problem. So that would mean moving 4x. How are we going to move it? Good. We're going to subtract 4x from both sides. So negative 1x plus 1 equals negative 7. All right. Don't call me after. What's the A stand for? Add or subtract. So what are we going to add or subtract? 1. And we're going to subtract it from both sides. So negative 1x equals, what's negative 7 minus 1? Negative 8. And we're going to finish this off by dividing both sides by negative 1. So x equals 8. Now, could we have moved the 3x to the right side of the problem? Yes, and some of you might prefer that because moving the 3x over would have given you a positive 1x and you wouldn't have had a negative to work with. I'd be okay with that, all right? As long as when you're done, it reads x equals 8, I'm okay with either of those. All right, let's check this one. Let's check this one. We have the square root of 3 times 8 plus 1, and it is supposed to equal the square root of 4 times 8 plus, minus 7. So what is 3 times 8? Plus 1? Makes this the square root of 25. And what is 32 minus 7? I just told you what 4 times 8 is. 4 times 8 is 32, minus 7 is 25. So really, we can stop right here. We don't even have to go to 5 equals 5 because the radicals are the same. So we can move on. All right, now look at letter F. Look at letter F. What do you think we're going to do? Somebody raise your hand and tell me what you think we're going to do to solve letter F. Caleb. What do you think we're going to do to solve letter F? First of all, do you think we still need to isolate the radical part of the problem?
No.
Where's Caleb? Caleb. Yeah, Caleb. Do you think we still need to isolate the radical part of the problem? Okay, but we do need to isolate it, but it is already isolated, okay? So what do you think step number 2 is going to be? However, look at the root of this problem. What's the root of this problem? So you want to try again? What do you think we're going to have to do to both sides? To undo a cubed root, we're going to have to do what to both sides? If to undo a square root, we square both sides, how are we going to undo a cubed root? Cube it. Very good. So once again, I would rewrite the problem so that you can see what the original problem was. The cubed root of 3c plus 7 equals 10. we are going to cube both sides. So the method is still the same, but we've got to be careful. Whatever the root is, that's the power we're going to raise the problem to on both sides. So what do you think the cubed root, Caleb, I'm going to stay with you. What do you think the cube root of 3c plus 7 cubed is? 3c plus 7. Perfect. Now that equals, what's 10 cubed? 1,000. Awesome. And now we got to solve for c. Talmadge, what are we going to move first so we can solve for c? How are we going to move it? Good. So we have 3c equals 1,000 minus 7 is 993. And JC, how are we going to finish this?
Divide 3.
Good. We're going to divide both sides by 3. So c equals 331. Awesome. Now box it in, but we still got to check it. We've got the cubed root of 3 times 331 plus 7, and that is supposed to equal 10. Now, when you grab your calculators, make sure you're putting in the cubed root. All right? On my calculator, you have to hit the shift button and then the square root button, and that gives you the cubed root. And be very careful underneath, because when you're doing the cubed root, it's 3 times 331, so I would put that in parentheses, close the parentheses, and then add the 7. Otherwise, it's going to give you some weird answer. So what is the cubed root of 3 times 331 plus 7? 10. Does 10 equal 10?
Yep.
Then we're good, and we can move on. All right, so we move on to letter G. What is the radical part that we're trying to isolate? Okay, the square root of 3m, which means we're going to have to move what first? How? We're going to subtract it, okay? So we have the square root of 3m equals, what is 1 minus 10? Negative 9. All right, Jamara, how do we get rid of the radical? We're going to square both sides. So Daniel, what's the square root of 3m squared?
Can I stand up quick?
Yes, what's the square root of 3m squared?
3M.
3m. And Daniel, what is negative 9 squared?
Negative 3.
Be careful.
3.
First of all,
Oh,
you're,
it's square, it's square.
yeah, don't square root it.
Negative 81.
Okay, but is it negative?
Oh.
Listen, anytime we square something, our answer is positive. So it's not negative 81, it is
Positive 81.
positive 81. All right? Malcolm, how do we solve for m? Divide both sides by 3. So m equals? Anyone? 27. Let's box it in. And then let's go check it. So we have 3 times 27 plus 10 is supposed to equal 1. All right? What is the square root of 3 times 27?
9.
Somebody besides Travis. What is the square root of 3 times 27? 9. And what is 9 plus 10? Does 19 equal 1? Look at this. We finally have an extraneous solution. So we go cross out m equals 27. And since that was the only answer, what are we writing down as our final answer? No solution. See, if we'd had more than one answer and one worked and one didn't, then we wouldn't have to write no solution. But 27 was the only answer. So since it doesn't work, the final answer is no solution. All right. But look, you see, this wasn't a weird problem, right? We got to 27 really easily, but that doesn't mean that it actually works in the problem. All right. Now let's look at letter H. And I want you to grab your highlighters and I want you to do 2 things. I want you to go back to that cubed root problem and I want you to highlight that little 3, that little cubed root, because I want you to remember you got to pay attention to the root. All right. The method was pretty much the same, but you had to cube both sides instead of square. So that's the first thing. The second thing I want you to do is I want you to highlight letter H, because letter H, you're going to see where things that we've learned in the past come into play here in a big way. Okay, so let's just work through the problem, but I want you to pay really close attention. We are supposed to do what first?
Isolate the.
Okay.
the radical.
We're supposed to isolate the radical. Is the radical isolated?
Yes.
All right. So what are we supposed to do to get rid of the radical? Square both sides. So again, I'm going to rewrite the problem so I have the original. And I'm going to square both sides. Now let's go ahead and do the radical side because we know the square root of 7p plus 15 squared is going to be what? 7p plus 15. But what are we being asked to do on the left side of the problem? What are we squaring? Which is a what? Two terms. It's a binomial. So listen, we are now back in chapter 7, chapter 8, where we learned how to multiply a square of a binomial. It's a shortcut problem. Okay? Remember, we can do p plus 1 times p plus 1 in FOIL, but we learned a shortcut. So if I'm you and I'm really trying to take good notes, I'm writing square of a binomial. Okay? I'm reminding myself this is the square of a binomial and there is a shortcut to multiplying it. Now, raise your hand if you remember. What do we do first when it's a square of a binomial? What do we square first? The first term. What's the first term? P. So we have p squared. How do we find the middle term?
You add. No.
What's the little bitty equation that we have used over and over again to find the middle term? 2ab. So 2 times, what's our a this time? P. And what's our b? 1. Good. So 2 times p times 1 equals what? 2p. There's our middle term. And then how do we find our third term? We squared the first term. We've done 2ab for the middle term. And now we square the second term, which is 1. So 1 squared equals 1. Now look at this problem. For the first time, we have a squared term, we have a p term, and we have a constant. So we have to go back to what we just tested on yesterday. How are we going to solve for p when there is a p squared, a p, and a constant? How many options do we have? How many options do we have for solving this problem? 4. Okay, let's list them really quickly. What are they?
Substitution.
Okay, no, you're on. That's a system.
Oh.
Complete the square.
Quadratic.
Quadratic formula. X factoring. Square roots. Perfect. So we have options. Okay. So what are we going to do? What do you guys want to do?
Quadratic.
Okay. You could. It's not going to be the quickest in this case. So let's pick the quickest since we're doing notes right now. Let's do the quickest. If you're on your own and you want to do the quadratic, go for it. Okay. But the leading coefficient is a 1. So what would actually be the quickest method? Factoring. Absolutely factoring. So we have to get everything where? On one side. Now, Travis, this is where I'd be okay with doing all of our steps at once because there's so much involved in this problem. So 7p to the other side, how do we do it? Subtract 7p from both sides. Move the 15, how? Subtract 15 from both sides. So we have p squared minus 5p. What's 1 minus 15? Everybody? Negative 14. And of course it equals 0. All right, let's factor. What goes at the top of our x? Negative 5. What goes at the bottom?
Negative 14.
Negative 14. Will our signs be the same or will they be different?
Different.
They will be different. We need factors of which number?
14.
So 1 times 14, 2 times. Are we going to be adding these numbers or subtracting them? To get 5. Okay, the signs are different, so we're going to be subtracting. Which set can we subtract and get 5?
2 and 7.
2 and 7. All right. Which one is going to be our negative? 7 is our negative because we need a negative 5, and 2 is our positive. So what are our binomials going to be? P plus 2, P minus 7, and we have to bring down the equals 0. Now, what do we do next? Tristan, if we want to solve for P, what are we going to do next? Okay, make 2 equations, take each binomial and set them equal to what? 0. Good. P plus 2 equals 0. P minus 7 equals 0. How do we solve for the first P?
Add 7.
The first P. Subtract 2. Good. So P equals negative 2. How do we solve for the second P? We add 7 and P equals 7. Now, are we finished? No, we've got to check both answers. So let's go back up here. We have negative 2 plus 1, and it's supposed to equal the square root of 7 times negative 2 plus 15. So what is negative 2 plus 1? Negative 1. And again, if you grab your calculator and you do the square root of, I would put in parentheses 7 times negative 2, close those parentheses, and add 15, and what do you get? You get 1. Does negative 1 equal positive 1? No, so P equals negative 2 is not one of our answers, so we exit out. Now we check our 7. 7 plus 1 equals the square root of 7 times 7 plus 15. What is 7 plus 1? 8. And again, we do the square root of, in parentheses, 7 times 7 plus 15. And what do we get? What do we get? Does 8 equal 8? Then what is our only answer to this problem? P equals 7. And that is lesson 10.3.